Section 5, Part 1, Integrating with API Gateway. This slide shows an architecture that is similar to one described earlier in this module. We'll take a closer look to learn a little bit about the API endpoint. An API endpoint type refers to the host name of the API. The endpoint type determines how the API's endpoints, the front end, are deployed and how clients access them. The API endpoint type can be edge optimized, regional, or private, depending where the majority of your API traffic originates. With REST APIs, you have the option of an edge-optimized endpoint. With this type, API Gateway uses its own Amazon CloudFront distribution to reduce the round-trip time for your requests and responses. This endpoint type is designed for globally distributed clients. It gives you built-in distributed denial of service, or DDoS, protection through its CloudFront distribution without your needing to set up a separate CloudFront distribution. This option is not available for HTTP or WebSocket APIs. All of the API types, which include REST, HTTP, and WebSocket, support regional endpoints. Regional endpoints are recommended for general use cases and are designed for building APIs for clients in the same AWS region. Note that a best practice is to set up a CloudFront distribution in front of regional endpoints. Websites and other externally focused services will access these endpoints. CloudFront helps to protect against DDoS attacks and to reduce the round-trip time for requests and responses. REST APIs also provide the option of private endpoints, which are accessible from only within Amazon Virtual Private Cloud, known as Amazon VPC. This endpoint type is designed for building APIs that are used internally or by private microservices. In general, you can write your API calls by using HTTPS requests to an API Gateway endpoint. Alternatively, you can use the API Gateway option to export an SDK for your defined API. Then, you can use that SDK with your client-side code to make calls to the API. To call your API programmatically, you must generate a platform or language-specific SDK for it. API Gateway generates custom SDKs for mobile app development with Android and iOS, and for web app development with JavaScript. API Gateway also supports generating SDKs for Ruby and Java. After an API and its models are defined in API Gateway, you can use the console to generate and download a client SDK. Alternatively, use the API Gateway APIs to do so. Client SDKs are generated only for REST APIs in API Gateway. For example, suppose that you're using AJAX calls on your dynamic website. You could generate the JavaScript SDK for your API and use the generated SDK to write calls to the API. When you write your own integration this way, you must have the client send a securely signed payload to your AWS account. In this example, the client is a website that uses JavaScript. Using the generated SDK, you send the securely signed payload to the AWS service endpoint for API Gateway. AWS can unpack that payload and deliver it to API Gateway what it needs to respond to the call. AWS awaits a response, packages it, and sends a secure payload back to the SDK. The SDK converts that message into a response that the JavaScript can work with. Although the generated SDK for the API simplifies coding this integration, the code to build the request payload from the client-side SDK is non-trivial. Additionally, it forces you to work with the API credentials on the client side, which is a bad practice from a security standpoint. For these reasons, the recommended approach is to use HTTPS requests to your API Gateway endpoint. This approach is simpler to code and more secure. As a developer, be aware of this option with use cases where it makes sense to connect to the AWS service directly with the SDK. Note that every time you update an API, you must redeploy it and regenerate the SDK to include the updates. Thanks for watching. We'll see you in the next video.